Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, in this video we will present about protein line parallel and the angle of triangle. Before that, I will introduce my team. The first speaker by Arif Pong Simpin, the second speaker by Alia Khairin Nisa, and the last speaker it's me Pahriani Dwi Putri. Let's get started.
Thank you for opportunity given to me. I will discuss about proving lines parallel. Postulate 11. If two parallel lines are cut by a transversal, their corresponding angle are congruent. We take the example picture on the side. The corresponding angles are congruent. Angle 1 congruent to angle 5, angle 2 congruent to angle 6, angle 3 congruent to angle 7, and angle 4 congruent to angle 8. Theorems 2.1.2. If two parallel lines are cut by a transversal, the alternate interior angles are congruent. The alternate interior are congruent is angle 3 congruent to angle 6, angle 4 congruent to angle 5. Theorem 2.1.3. If two parallel lines are cut by a transversal, then the alternate exterior angle are congruent. We take the example picture on the side. The alternate exterior angle are congruent is angle 1 congruent to angle 8, angle 2 congruent to angle 7. Theorem 2.1.4. If two parallel lines are cut by a transversal, then the interior angles on the same side of the transversal are supplementary. Theorem 2.1.5. If two parallel lines are cut by a transversal, then the exterior angle on the same side of the transversal are supplementary. Theorem 2.3.1. If two lines are cut by a transversal so that the corresponding angles are congruent, then these lines are parallel. Given L and M cut by transversal T, angle 1 congruent to angle 2. See figures 2.16. Proof L parallel to M. Proof suppose that L parallel to M. Then a line R can be drawn through point P that is parallel to M. This follows from the parallel postulate. If R parallel to M, then angle 3 congruent to angle 2 because these angles correspond, but angle 1 congruent to angle 2 by hypothesis. Now, angle 3 congruent to angle 1 by the transitive property of congruence. Therefore, M angle 3 congruent to M angle 1, but M angle 3 plus M angle 4 congruence to M angle 1. Substitution of M angle 1 for angle 3 leads to M angle 1 plus M angle 4 equals M angle 1. And by subtraction M angle 4 equals to 0. This contradicts the protractor postulate, which states the same measure of any angles must be a positive number, then R and L must coincide, and if follow that L parallel to M. Theorem 2.3.2. If two lines are cut by a transversal so that the alternate interior angles are congruent, then these lines are parallel. Given line L and M, transversal T, angles 2 congruent to angle 3, see figures 2.17. Proof L parallel to M. Plan for the proof so that angle 1 congruent to angle 2 correspond angles. Then they apply theorem 2.3.1, in which congruent corresponding angle S imply parallel lines. Proof statement L and M trans T angle 2 congruent to angle 3. Reasons given. Statement angle 1 congruent to angle 3. Reasons. If two lines intersect vertical, angle S are congruent. Statement angle 1 congruent to angle 2. Reasons. Transitive property of congruence. Statement L parallel to M. Reasons: if two lines are cut by a transversal so that chord angle S are congruent, then these lines are parallel. Theorem 2.3.3. If two lines are cut by a transversal so that the alternate exterior angle are congruent, then these lines are parallel. In a more involved drawing, it may be difficult to be decided which lines are parallel because of congruence angle. Consider figure 2.18 on page 88. Suppose that angle 2 congruent to angle 3, which line must be parallel. The resulting confusion. It appears that A may be parallel to B and C may be parallel to D can be overcome by asking which line help from angle 1 and angle 3. In this case, angle 1 and angle 3 are formed by line A and B, which C as the transversal thus up parallel to B. Example, in figures 2.18, M angle 3 equals to 94 degrees. Find M angle 5 such that C parallel to D. Solution, with B as a transversal for line C and D. Angle 3 and angle 5 are corresponding angle. Then C would be parallel to D if angle 3 and angle 5 were congruent. Choose M angle 5 equals to 94 degrees. Theorem 2.3.4. If two lines are cut by a transversal so that the interior angles on the same side of the transversal are supplementary, then these lines are parallel. Example, proof Theorem 2.3.4. See figures 2.19. Given line L and M transversal T, angle 1 is supplementary to angle 2. Proof L parallel to M. Proof statement L and M trans T. Angle 1 is up to angle 2. Reasons given. Statement angle 1 is up to angle 2. Reasons: if the exterior sides of two adjacent angle S from a straight line, these angle S are supplementary. Statement angle 2 congruent to angle 3. Reasons: if two angle S are supplementary to the same angle, they are congruent. Statement L parallel to M. Reasons: if two lines are cut by a transversal so that corresponding angles S are congruent, then these lines are parallel.
I will continue the explanation from my friend. I'm Alia. I will explain from page 89. I will continue from theorem 2.3.6. The theorem says if two lines are each parallel to a straight line, then these lines are parallel to each other. If they are two parallel lines and we give the third line parallel to two lines, the three lines are parallel. These lines are parallel to each other. Theorem 2.3.6 is true even if the three lines described are not coplanar. In theorem 2.3.7, the lines must be coplanar. See that theorem 2.3.7, if two coplanar lines are each perpendicular to a straight line, then these lines are parallel to each other. From example, we see from example 5. For given line AC perpendicular with line BE and line DF perpendicular BA, lines BA, we will prove that line AC parallel line AC parallel line DF. The way to prove that, we use four ways. First, we know that statements are given AC perpendicular line BA and line DF perpendicular line BA. Reasons given. Angle 1, see that angle 1 and angle 2 are same. The reasons, if two lines are perpendicular, they meet to form right angle S. So the angle, the third, angle 1, we have a transversal line BE, transversal line. So using a theorem before, we can conclude that angle 1 is congruent angle 2 because angle 1 and angle 2 is particular. We can conclude that line AC is parallel to line DF. The example 5 is give us illustration for theorem 2.3.7. Okay, we will continue. Try to answer number 18. Reasons. We must fill the blank statement. I think we are given L and angle 3, angle N parallel to N. Line L parallel to M are given. Next, line angle 1 equal angle 2 because they are exterior. And number 4, statement is given angle 3 equal to angle 4, and the last is we prove that line L equal to N. Okay, that's explained from me. I'm so sorry for my mistake. Thank you.
Hola guys, I will sharing what I know about the angle of triangle. We know that triangle is the union of three line segments that are determined by three non-collinear points. You can see the figure in the left side that the figure is known as triangle ABC or triangle BIC and etc. Each point A, B, and C is vertex of the triangle. Collectively, the 3 points are the vertices of the triangle. Line AB, line BC, line AC are the sides of the triangle. Point D is in the exterior of triangle. Point E is on the triangle and point F is in the interior of triangle. Table 2.1 is triangle classified by congruent side. The first type is called scalene triangle. We know the figure has non-congruent side. The second type is called isosceles triangle that have two congruent sides, and the last is equilateral triangle have three congruent sides. Table 2.1 is triangle classified by angles. The second type is acute. The triangle has all angles acute. The second is obtuse, that the triangle had one obtuse angle. Next is right triangle, that triangle had one right angle. And the last is equilateral triangle, that the triangle had all acute congruent. Or we can say the angle had 60 degrees. Theorem 2.4.1. In a triangle, the sum of the measure of the interior angle is 180 degrees. Let's prove the theorem 2.4.1. Given triangle ABC in the figure, prove M angle A plus M angle B plus M angle C equals 180 degrees. Prove talk C. Draw line AD parallel with line AB. We see that M angle 1 plus M angle 2 plus M angle 3 is equal 180 degrees. But we know that M angle 1 equal M angle A and M angle 3 equal M angle B because alternate interior angle are congruent. Then M angle A plus M angle B plus M angle C equal 180 degrees. So, proven. Next, corollary 2.4.1. In a triangle, the sum of the measure of the interior angle is 180 degrees. Corollary 2.4.2. Each angle in an equiangular triangle measure 60 degrees. Corollary 2.4.3. The acute angle of right triangle are complementary. Corollary 2.4.4. If true angle of one triangle are congruent to true angle of another triangle, then the third angle are also congruent. And the last corollary 2.4.5. The measure of an exterior angle of triangle equals the sum of the measure of the two non-adjacent interior angle. Let's go to try to answer this question. The first step, we can draw the triangle ADE. Angle D equals 70 degrees. Angle E equals 70 degrees, and we want to find angle A. So the sum of the angle of triangle is 180 degrees. You can see this video what we want to do. 180 degrees equal angle A plus 70 and finally angle A equal 40 degrees. Next, we want to find the angle of ADB. So we know that angle ADE plus angle ADB equal 180 degrees. Next, 70 plus angle ADB equal 180 degrees. So angle ADB equal 110. Now we can find the angle B. Angle B equal 180 degrees minus angle A minus angle D equal 180 degrees minus 30 minus 110. So the result of the angle B equal 40 degrees. We think it's enough. Thank you guys for your nice attention to watching this video. Wassalamualaikum warahmatullahi wabarakatuh.